Designing a database for a school seems like it should be pretty simple. It's just students, teachers, and classes, right? But there's much more to it than that. In this video, I'll show you step by step how I would design a database for a school management system. We'll look at each of the requirements of this new database and adjust the design to include it. The main difference between this kind of design and other school or university designs is that this will allow students to move to different year levels, like a primary school or a secondary school. Let's get started. Welcome to the Database Star YouTube channel, the place for developers looking to improve their database and SQL skills. So how are we going to do this? We'll start with a blank page. This is a tool called Lucidchart, which is what I use for database designs. You can use pen and paper or any other tool you are familiar with. I've got a list of requirements for our school database, which we'll go through one at a time. We'll then add tables and columns to ensure the requirement is met. At the end, we'll have a database design that meets all requirements. I'll then explain a few requirements or features that I left out on purpose. You could use them to make possible enhancements to the design if you like. So what's the first requirement? We want to store information about students. For a student, we store their name, gender, date of birth, and when they enrolled at the school. Let's add our first table to the diagram. We'll drag a table element from the left panel here onto the diagram. I've chosen this element because I want to record primary and foreign keys and column names, but for now I don't care about the data types. So we'll call this table student. I'll give it an ID field as a primary key, which is pretty standard, and I'll do this for every table. We then add in 3 more columns for the name: given name, middle name, and surname. This allows data to be filtered and ordered based on different parts of a name. Next, we add in the other information we want to store. This includes the date of birth, the gender, and the enrolment date. I'll add a link to an image of this diagram in the description below, so you can download it for your own reference. Here is what this student table could look like with some sample data. We can see a few students here. Our design now meets requirement number 1. What's next? Requirement number 2 is about storing information about parents, grandparents, and other carers. We want to store their names and contact information. Now, we might be tempted here to create tables for parents and relate them to grandparents and have another table for carers. However, there is a simpler solution. Rather than create separate tables, we could create a single table to capture all of these people. We could call them guardians, as they are the people who care for or are responsible for the students. Another name could be carer, but we'll go with guardian for this example. We add a new table called guardian, and inside the table we add in an ID, a given name, a surname, an email address, and a phone number. We don't need to have a middle name like we did for students. How do we specify the guardians for each student? The requirement says that a student can have multiple guardians, such as a mother and father or a mother and grandmother. A guardian could have multiple students if there are multiple children in the family. So this is a many-to-many relationship. So we need a joining table. We'll add one here and call it student guardian. We store the student ID and the guardian ID. Something that might be helpful would be to store the type of guardian that the person is. This could help when teachers need to contact them. We could have a defined list of guardian types, such as mother, father, grandmother, parent, and so on. How do we relate this? The type of guardian is an attribute of a guardian's relationship with a student. So we can add a foreign key to the student guardian table to capture this field. We have now met requirement number 2. Here is some sample data for the tables we just added. We have the guardian type table here with some options in it. The guardian table has a few people in it as well. The student guardian table has the links to the student and guardian tables as well as the guardian type table. They can all be joined in a query to get the data about students and guardians. Requirement number 3 is about school years. A school year has a start and end date. It can also be within a single calendar year or over multiple years. For example, the school year in Australia may run from January to December, but in the US I think it runs from September to the following June, which is over 2 calendar years. In our design, we can create a new table for the school years. We'll give it an ID as well as a start and end date. These would be some kind of date data type, so it would capture the day, month, and year. We may also want to add a name column, so we could name the year if it needs to be shown on screens or reports. I think that the requirement is met now. We haven't related this table to anything else yet, but we'll probably learn more about it in the upcoming requirements. The data in this school year table may look like this. There are some records with different dates and they have names. The next requirement is about terms. A year has multiple terms which have dates, and there's no specific number per year. This means a year could have 2 terms or semesters, or 3 terms, or 4, or any other number. Back on our design, we'll add a new table called term. We'll give it an ID column as well as a year ID column so we can relate it to the school year table. We could also add a term number column so we can identify the term within the year, such as term 1 or 2. We'll also add the start and end date of the term, as that was mentioned in the requirements. Requirement number 4 is now met. The term table could look something like this. We've got some sample data with dates and some names. We can relate them to the school year table as well. Requirement 5 mentions that students are enrolled in one level at a time, such as Kinder, Grade 1, Grade 2, and so on. They can move to other levels. Let's add this to our design. We can start with the concept of levels. A level would be the different grades or levels available in the school, such as Kinder, Grade 1, Grade 2, and all the way up to Year 12 or whatever the school goes up to. So let's create a table for this. There are a few names we could use for this, but I'll call the table year_level. I'll add in an ID and a name for the level, which could be the Kinder or Grade 1 value. I'll also add a column called level order. This would be a number value and would be useful for sorting the level data if it needs to be added to a drop-down or shown in a report. We may not be able to do this just based on the names of the levels. How do we capture the relationship between students and levels? We know that students are in one level at a time, but they can be in more than one level during their time at the school. So we'll need to add a joining table, as this is a many-to-many relationship. We'll call it student year level. We add in the student ID and the level ID as foreign keys. Another column we may want to add is the school year. With just the student ID and level ID, we can say that student John Smith is in the year level 3, but we don't know when this is, or what school year it is for. Adding the school year ID will allow us to do this. I think this means that requirement 5 is now met. Our year level table may have some data that looks like this. The student year level table data could look like this here as well. We can see how it has some IDs for the related tables. The next requirement mentions that students are part of classes and can be in more than one class at a time. Let's see how we can add this. We don't know a lot about classes, so we'll add a table for it and leave it mostly empty. We'll call it class and add an ID column for now. We know that students can be in more than one class, and a class has many students. So we'll need another joining table. We'll call this one student class and add the IDs of both the student and the class table. The sample data for this will just be the ID values, so there's not much to show yet. What's next? The next requirement says that classes have subjects, such as sport or physics. Let's add this to our design. We'll add a new table called subject, which will have an ID and a subject name. We can relate this to our class by adding a subject ID into the class table. This is a pretty simple addition to our design. What does the sample data look like? We've got a subject table here with some subject records. Our class table could look like this, which just has IDs, but they can be linked to subjects and students. Requirement 8 says that subjects belong to departments. This can be helpful if we want to see all of the science subjects or classes, for example. In our design, we add a new table called department. This is similar to subject, as we have an ID and a name column. In the subject table, we need to specify which department it belongs to. We do this by adding a department ID foreign key to the subject table. We can now relate departments to subjects and then to classes. Here's what the sample data could look like. We've got a list of departments here with IDs and names. In the subject table, we can see how the departments relate to these subjects. We're over halfway there. This is requirement number 9 of 16. This requirement says that a class is taught by a teacher. What does this look like for our design? We could just add a new field to the class table to specify the teacher name. However, we could assume that we need to know more about teachers. We may also recognise that teachers are entities in our design and not just an attribute of something. So let's create a new table for them. Our new table will be called teacher. We'll just have an ID for now. We then join it to the class table. A teacher can have many classes, but a class can only have one teacher. So we add a teacher ID to the class table. Let's go to the next requirement. The next requirement shares more about teachers and mentions they have names, genders, and contact information. For our design, this means we can add a few more fields to our teacher table. We'll add a given name, a surname, a gender, an email address, and a phone number. Here are some sample data for our teacher table. We can see that along with the IDs, we have some names, gender, and contact details. Requirement 10 is now met. The next requirement is about classes and terms. It says classes are related to terms. There can be multiple classes for the same subject in a term. We also have a name to help describe the class. In our design, we can make a few changes. We add a term ID to the class table. This is another way that students are related to years. They are enrolled in classes that are part of a term within a year. Adding this relationship allows us to have multiple classes in a year and multiple classes in a term. The next part of the requirement is having a name for the class, which is achieved by adding a name field to the class table. Here's what our class table could look like now. We have a few ID fields as well as a name field. Requirement 12 is about classrooms. Classes are held in a classroom. There are types of classrooms, and a classroom has a name and a capacity. In our design, we'll add a new table called classroom. It has an ID just like the other tables. We'll also add a room name and a capacity field. The concept of a type of classroom can be stored in a separate table. We'll call this classroom type and give it an ID and a name. We'll relate this to the classroom by adding the type ID to the classroom table. Next, we need to specify the classroom that a class operates in. We can add the classroom ID to the class table. This does not currently allow for a class to be in different classrooms at different times, so that's a possible enhancement to this design. What could these tables look like? The classroom type could have a few records like this. The classroom table related to it could have a few records here. Notice that the name field is a mix of letters and numbers, which could be used as a reference on a map. The next requirement is about when classes occur. This time is called a period. There are a certain number of periods per day, and they are set for the entire school year. How do we add this to our design? We add a new table called period with an ID column. Then we add a start time and end time. This indicates what time of the day that the period starts and ends. We need to relate this to the school year so we can add the ID of the year to this table. Finally, we can give a period a name so we can understand them on a screen or when referring to them. Our period table could look like this. We have a few records with different start and end times, and each of them have different names. Next is requirement 14, which says that a class can occur over multiple periods. We could do this in a few different ways. We could have a joining table that has a record for each combination of period and class. Another way is to record the starting period and ending period in the class table. This means the design will be simpler, but we are limited by having a start and end period. I think this is a fair limitation. It's unlikely that we would have a class that happens in period 1 and period 3, for example. So let's add these two columns to the class table. We then link the period table to both the start period ID and end period ID columns. Requirement 15 out of 16 is about student grades. Students are graded based on their work in a class and get a score from 0 to 100. They also have an overall score for the year. In our design, we can achieve this requirement by adding a score column to the student class table. We add it here because we want to capture the score for each student for each class they are in. It's a single field and will be a number. We also need to capture the score for the overall year. We do this by adding a score column to the student year level table. This allows us to capture a score for each combination of student, year level, and school year. Here is what the student class table would look like with this score column. The student year level table would look very similar with the new column. Our final requirement is how the scores are matched to a letter grade. Each grade has a range of scores that are used, for example 0 to 50 and 51 to 60. Let's add this to our design. We need to create a table that stores these letters and what scores they relate to. We'll add a new table called Score Range. We have an ID and a grade, which is the letter. We'll add two columns here, one for the min score and one for the max score. This means that we would get the score from the student class or the student year level table, see which of these records it matches to, and find the grade. Using this min and max concept makes the query easier to write, but does allow for overlapping ranges, which is not ideal. Another approach would be just to have a min score field and use a query to find the first record where the score is greater than the min score. Also, I haven't added any foreign key links here because these score values don't link to identifying columns or primary keys in the other tables. They can be used in joins but may use the greater than and less than operators. Now that we have this score range table, this is what it would look like. We can see some min and max values along with the letters. Here's the final database design. We started with one requirement and added one table at a time until we got to this design. We've got information about the students, teachers, classes, terms, years, and all of the enrolment and grades that go along with it. I've added a link to this diagram as an image file in the description if you want to refer to it. What's next? There are a few requirements that I deliberately left out of this design just to keep the video shorter. One of those was the ability to see which teachers belong to or can teach in a particular department. This would mean you can see all of the science teachers or help with allocating teachers to classes. Another requirement was the ability for a teacher to also be a guardian. We could do this by combining the two tables. In this design, if a teacher is a guardian, then they would have one record in each table. This design also does not allow storing results for different tests or assignments for a class, or recording student attendance for a class, or storing multiple phone numbers for teachers or guardians. If you want, you could take these requirements and this design and think about how you would enhance the design to meet these requirements. The next thing you might be thinking is, how do you actually create this database? I don't have the SQL scripts to create this school management database, but I do have a video on how to go from a database design to SQL code. It will show you how you can write the SQL code from a design like this. I hope you found this video helpful. Learning how different databases are designed can help understand the concepts in a realistic scenario. Let me know what you think in the comments, and if you have any requests for other database design videos. If you want to learn more about database design and SQL, visit my website at databasestar.com. If you liked this video, consider subscribing to my channel. Thanks for watching.